thanks for listening. This is Brian Hurley from Business Performance Improvement. The podcast Lean Six Sigma Bursts are short lessons, comments, Q&A, and insights. If you have a question, send your question through the Anchor app, and we might feature you on a future episode. Or contact me at biz-pi.com.
In Greenbelt, you might have learned about the one sample t-test and the two sample t-test, probably went through analysis of variance. And you might have learned about the correlation coefficient, or R value, which is studying the correlation between two continuous variables to see how well their relationship fits a linear relationship. Those are topics that you probably learned about in Greenbelt training, or your Greenbelt course. The equivalent to these parametric tests for each of these scenarios are listed over here. For a one sample test, we're going to look at a one sample sine or a one sample Wilcox. For a two sample t, we're going to look at the Mann-Whitney or the Moore's median. For ANOVA, we're going to look at the Kruskal-Wallis. And for the Pearson correlation, we're going to look at the Spearman rank. So we have equivalents for each of these parametric tests in the non-parametric test world. All right, so this is what we'll spend this section going through. Another reminder is as we get into these p-values, we have to think about what is the result of the p-value. If the p-value is less than 0.05, then we reject the null hypothesis. That is, no matter what test we're doing, that is always the conclusion, unless you change your alpha level to something other than 0.05, but that's very unlikely that we're going to do that. If you're above 0.05, then you do not reject the null hypothesis. So we stay with the null hypothesis. Usually that two groups are equal to each other, or the data is a normal distribution, or the slope of the relationship or correlation is flat or there's no slope. Something like that will be part of the different hypothesis tests.
Let me pause for a moment to tell you about our sponsor, Creative Safety Supply. Creative Safety Supply is a great resource for free guides, infographics, and continuous improvement tools. I recommend starting with their 5S guide. It includes breakdowns of the 5 pillars, ways to begin implementing 5S, and even organization tips and color charts. From red tags to floor markings, it's all there. Download it for free at creativesafetysupply.com/5S.
Let's say that you want to ride the ride. If you're not tall enough, you are going to get rejected off of the ride. Think about that in terms of p-values. If your p-value is too small, you're going to reject the null hypothesis. If your p-value is high enough, then you do not reject. Not sure if that helped you remember the difference, but the other thing that I've told people to use is this phrase: if the p-value is low, the null must go. If the p-value is too low, then you reject it or make it go away. Null must go. So someone came up with that as a way that kind of rhymed. The students I've talked to think that helps a little bit. Just trying to remember that. If the p is low, the null must go. So I'm just trying to help you remember when you see these p-values of how do you interpret these numbers. It's confusing to remember what to do with the different p-values. So if it's too low, then we reject it. This is a decision matrix I put together in the Greenbelt training. Based on the different hypothesis tests, what does the p-value less than 0.05 mean for that test? Let's take an example of what we looked at earlier today. We looked at the normality test. We said in a normality test, if the p-value is less than 0.05, we reject the null. But sometimes people forget what the null hypothesis is. The null hypothesis is that the data follows a normal distribution. So if your p-value is less than 0.05, you're saying that your data is not a normal distribution. And if it's greater than 0.05, then you're saying it is a normal distribution. If we're doing a correlation study, the null hypothesis is that the correlation equals 0. So if it's less than 0.05, then there is a correlation. And if it's greater than 0.05, then there's no correlation. It's a reminder of these different tests and what the decision is. But yeah, these are the parametric versions of these tests. Don't rely only on the p-value, look at the shape in the picture, or look at the probability plot or histogram as well. because this test in particular is very sensitive to large samples or small samples.
Whether you work in a manufacturing company, at a hospital, within a government agency, or volunteer at a nonprofit organization or NGO, continuous improvement is necessary and essential. For the past 25 years, I've been helping organizations implement Lean and Six Sigma methods into their culture. And I've compiled all this knowledge into the 7 best practices that are essential to any organization. If you sign up with your email, you will receive a link to the YouTube video, you will receive an audio podcast, and a summary document you can download. The video takes less than 30 minutes to listen to, and it will help you fully leverage the power of these methods and ensure your organization has a solid improvement culture and foundation. Go to biz-pi.com and look for the 7 Continuous Improvement Best Practices document.